Okay, so we did the derivatives already. We did like the derivative of natural log of like the ln of u function. We did that last time, right? And it was 1 over u times u prime. So now you're going to be integrating like 1 over u. Okay, so now it's like going backwards. Okay, so if you integrate 1 over u with respect to u, it's probably what you expect. It's natural log of u plus c. Now they put absolute value around it. Natural log, absolute value of u plus c. Why do they do that? Well, you probably know, or you might have heard before, that you can't take the natural log of negative numbers. Like if I grab a calculator, log, or even, here, I'll just grab a calculator. Natural log of like -3. See, you can't do natural log. It says non-real answer, you know, so you're like, okay. It says error on your calculator. You can't do natural log of negative numbers. So when we were doing the derivatives, actually last time, it did say in the book that that whatever the u is greater than 0. But, you know, it did say that in the definition in the book. I mean, we didn't really have to worry about it, because it was saying, like, when you take derivatives and this thing is greater than 0, it said that. So it's just like 1 over u times u prime. So yeah, in the definition of this, they say, okay, this u thing, yeah, it should be, we have to make sure it's something positive. So they put absolute value around it. Okay, so let's try a few examples with this. Let's try to figure it out. All right, so let's say we're going to integrate 2 over x dx. Okay, so these are the rules at the top. You know, that's the derivative, this is the integral. It's kind of like working backwards. Okay, so this one, okay, that's the integral is usually like 1 over x or 1 over u. I have a 2 in this one. Well, the 2 that's in the top, you can actually pull that out in front. The constant, the 2, can go in front, so it's like 2 integral of 1 over x dx. So constants can go in front of the integral. Constant is just like, it's still there, it's just off to the side so you don't have to worry about it. Okay, so what's the integral of 1 over x dx? Okay, so it's going to be 2 natural log, yep, of x plus c. Good job. Okay, now I would accept that answer. That'd be perfectly fine. I would also accept another answer. Another answer involves the power rule. You can move that 2 if you want. You can put that 2 back over as the power, you know, like x squared. That's that power rule with logarithms. You can pull the 2 back over here, x squared. If you have some x, the absolute values, you have absolute value there because you're trying to say that has to be positive, right? So if you have something and you square it, isn't it always going to be positive? If it's like something negative and you square it, it's going to be positive. So now if you rewrite it like this, you don't really need the absolute value signs anymore. Because if it's squared, that's going to be positive. So you could have the first answer, that's an acceptable answer, or you could have this answer. You could have either one of those answers. Those are right. So just realize that, like, I'm fine. Like, you could have it the first way or you could have it the second way. They're both correct answers. They're both the same thing. Okay, let's try another one. So let's say you have another example, an integral of 1 over 4x minus 1 dx. This is getting a little harder. It's not just 1 over x, you know, it's 1 over 4x minus 1. Nope. Because, yeah. You want to think of it like, figure out what u is, like we've done in the past. You want to do this u substitution. U is the bottom part, yeah, is this 4x minus 1. What's the derivative of u? You have to do u substitution like we learned, yep, so that's 4 dx. Solve for dx. Dx equals du divided by 4. That's going to go in there. So you do u substitution when you have like a whole bunch of stuff in the denominator. You're going to have to do u substitution. Okay, so now let's rewrite it. So now it's the integral of 1 over u. The 4x minus 1, that's my u. And the dx is du over 4. So there, now we can pull the 4 out front, the 1/4. So kind of in a roundabout way, like you kind of could see that, Gretchen. That's like, yeah, you know, like showing all the steps here. So you can put 1/4 in front of the integral and have 1 over u du. Now you could try to solve that. So now integrate it. What's the integral? How do you integrate 1 over u du? Yep. So it's going to be 1/4 natural log of u in absolute value plus c. Now you got to plug back in what u was. So that's the thing that people might forget at the end. If you know, a few of you forgot that. It's easy to forget. You think you're done. It's like, oh wait, what was u? Put back in what u is at the end. So it's 1/4 natural log of 4x minus 1 in absolute value plus c. Natural log of 4x minus 1 plus c. There we go. There's the answer. So what do you think? So you have u substitution on this stuff too, like we've learned. Okay, what else? Yeah. Yeah, I would just leave it like this. Yeah, she's asking, yeah, 1/4 power. You could put the power back up here, so that'd be a 4th root of all that. Yeah, 4th root. Because like a square root, you can have plus or minus. 4th root. You probably need it still. I know, that always gets iffy. I'm like, huh, I don't know. It starts getting confusing. Just leave it like this. It's easier. Yeah, if it's even, you might not need it then, huh? Yeah, it gets confusing. I even get confused sometimes. Yeah. Okay, so then, guys, it gets into finding area. You guys, when it says finding area, this came up on the last test. It said find the area, and you guys got confused. Integrating is finding the area. You just integrate like we've been doing the whole time. You just integrate. So, because there was like a question on the test like that. There was a question on the test last time that said find the area. You just integrate the problem. So, it was 9 for that one from the test. But yeah, like there was a question on the test that said find the area. So if it comes up again, find the area, you're just integrating. So it says find the area of the region bounded by And then they give you your function bounded by y equals x over x squared plus 1. And then they'll give you like they'll give you an x equals, like x equals 0, and x equals 0, x equals 3, and y equals 0. So if I did graph this one, I mean, I can like kind of graph it for you really fast. It'd be like they're trying to tell you to just go on the x-axis between 0 and 3. 0 to 3, right? And it's some kind of curve. Let me see if I think they had a picture of this one in the book. Yeah, it's like some kind of curve, some kind of curve like this. They're just trying to get you to go between 0 to 3. The y equals 0 is just this line. Y equals 0 is just this line. That just means, so see, it's just trying to stay like between 0 and 3 on the x-axis, and underneath it some curve, and above the x-axis. Y equals 0 is like the x-axis. Yeah, finding area is just integrating. So they're trying to tell you to integrate this problem, x over x squared plus 1. Yep, this problem from 0 to 3 dx. So they're just trying to tell you to take this problem, integrate it from 0 to 3. Okay, so let's do that. What's u? X squared plus 1. What is the derivative of u? 2x. So you're going to have to, so I wrote du equals 2x dx. Solve for dx, so divide by 2x. So du over 2x goes in here. Now rewrite your problem. See, we got this. It's not that bad. It's just doing the integrating. It just takes some time. So the bottom is your u part. Dx is du over 2x. The x's cancel out. Yep. Pull out the 1/2. Good job. So then you have 1/2, integrate from 0 to 3, 1 over u du. Okay, so what's the integral of 1 over u du? Okay, so we got 1/2 natural log of u. Okay, well, what was u? So you need to put that back in, x squared plus 1. Natural log of x squared plus 1. Now you evaluate that from 0 to 3. Natural log, that's u. Remember, it would have been natural log of u. It would have been 1/2, I can write it in red, 1/2 natural log of u. Nope, you don't need plus c. U is x squared plus 1. So I'm putting back in what u is. Or you could change your 0 to 3. We could have left it as a u and changed the 0 to 3 limits. You can do it that way too, like we've done before. Yeah, if you leave it as 1/2 ln u like this, then you could evaluate it from 1 to 10. Yeah, that was right. You could do it that way too, and you're going to get the same answer either way. Like, remember how we changed the lower and upper limits of integration if you don't want to put x back in? You can do it either way. We can do it plugging it back in too, so it doesn't matter. So let's see, what do we get? 1/2. If you put a 3 in there, 3 squared is 9 plus 1 is 10, so you get the same answer. ln, natural log of 10 minus what? Natural log of 1. What's natural log of 1? Yeah, natural log of 1 is actually 0. So your final answer is what? 1/2 natural log of 10. they actually solve it in the book and put the decimal for that. So ln of 1 we're saying is 0. It actually is 0. ln of 1 is 0. So it's really just ln of 10 minus 0, so it's just ln of 10. And then what's 1/2 times ln of 10? Let's see what that is. 0.5 times ln of 10. The book final answer is, what, 1.151? Yeah, that's what the book has. Okay, so, just pausing here a sec. So, you could, if you want, you could change this 0 to 3 to 1 to 10 by plugging the 0 to, you remember how we plugged it into the U problem? If you plug 0 into this U problem, you get 1. If you plug 3 into there, you get 10. You can evaluate ln U from 1 to 10. Or you can put back in what U was and leave it as integrating from 0 to 3. See, it's like,
the same thing, but different ways.
Yeah, the same thing 2 different ways. So if you like, I do actually kind of like to just leave it as a U because it's less letters and numbers and all that to deal with. So it's like a shortcut because then you just have to put in 10, 1 to 10, so it's ln of 10 right away instead of doing it that way and having it. I don't know, it's like the same thing, just 2 different ways. ln of 10 minus ln of 1. We did it. Okay, so the 3, if you put a 3 in there, 3 squared is 9. 9 plus 1 is 10. ln of 10. And if you put a 0 in there, you get a 1. ln of 1. ln of 1 is 0. The U is x squared. I don't know where you go.
No, it's like that.
No, I
That's
get it.
why I did the
10 minus 1, I get it. That's what 3 minus that's that.
Yeah.
That's right.
Yep. Okay, let's see. I think there's one more thing I got to show you, and then you guys can work. Because there's one more problem you could encounter. Like one more different kind. All right, so the ones we just did, weren't you noticing that we're trying to get like 1 over U, right? So I think you were noticing that the bottom of the fraction is usually the U part, right? Okay, so maybe I don't know if you're noticing or not, but like this one too, you might have noticed we did it again, the bottom part was the U. And then when you took the derivative of that x squared was 2x, and that 2x, like that x ended up canceling the other x in the numerator. So you might notice that the denominator is usually like a higher power. This was x squared, and then the derivative of that was an x, and it cancels the x up there, Well, there's a problem sometimes. That's what. The problem can happen when, okay, we are saying usually the U is the bottom part of the fraction. So I'm going to write one out. X squared plus x plus 1 over x squared plus 1. Okay, usually the denominator is the U part of the problem. And then usually you take the derivative of that bottom part and it'll help cancel out something in the numerator, Like that last one we just did. The 2x canceled the x. The dividing by the 2x. Well, we got a problem here that, because I see the same power in the numerator and the denominator. Same power in the numerator and the denominator. So I know that's going to give me a problem. Because if I think the U is the bottom part, the derivative of the bottom part is 2x, that's not going to cancel out an x squared. It just is not going to work out. So if you start noticing that, if there's the same power in the numerator and the denominator, or if the numerator has a higher power, or if the numerator has a higher power, higher degree, then you're going to have to do something. You're going to actually have to do long division before integrating. Long division before you integrate. So if there's the same power, like in the numerator and the denominator, or if the numerator actually has the higher power, the higher degree, then you're going to have to do long division first before you can integrate. So, reviewing long division. Okay, the numerator says x squared plus 1x plus 1. You need to divide that by x squared. Okay, now when you do the division, I think it helps if you fill in missing powers. Like the bottom of this that I'm dividing by, it just says x squared plus 1. Well, do you notice it doesn't just have an x? So I like to put x squared plus 0x plus 1. I like to fill in missing terms. Fill in missing terms. Like I'm dividing by x squared plus 1, really like x squared plus 0x plus 1. There was no x in that bottom part. Okay, long division. You have to think, what times the x squared out here, what times x squared gives you x squared? 1, yeah, just 1, okay. 1. I filled in missing terms. Yeah, like this is missing an x squared, an x. So I just put a 0x. It just helps for like placeholders and making sure everything lines up good when you're adding and subtracting things. So yeah, now if I do 1 times x squared over here, you get x squared. If you do 1 times 0x, you get 0x. And 1 times 1 is 1. We're actually just doing this right now in Algebra 2. Now you have to subtract. When you do the long division, you have to like times and write it underneath, then subtract. So if I subtract 1 minus 0, that's 1, 1x. 1 minus 1, okay, that's nothing. Okay, so I just get 1x. Because this cancels. Okay, so I'm basically done. I know it's kind of weird, but I divided it and I ended up with a 1 at the top. I ended up with 1 plus my remainder. Remember, this is your remainder. And what do you do with the remainder? You put this 1x that's left, this x, you put it over what you were dividing by. Yeah, what were we dividing by? X squared plus 1. You don't need the 0x now. I just had it in there as a filler to make sure everything lined up good when I'm doing long division. So I did long division. Now I can integrate this problem. Now I can do it. Okay, how do you integrate the number 1? Yeah, that'd be x. Plus. Okay, how are we going to integrate this part? Well, the bottom is the u. The bottom part, the x squared plus 1, that's the u. So I already integrated this part. It's kind of like I'm doing it in 2 steps. I already integrated that. That's x. So now I'm trying to integrate this and rewrite it and stuff. So the bottom's the u. What's the derivative of this u stuff? 2x. Okay, solve this for dx. So du divided by 2x. Okay, so this dx, I replace it with du over 2x. See, it's hard, isn't it? It's a lot of steps to do. So then the x, yeah, the x cancels. Okay, so I have x plus 1/2 integral of 1 over u du. Okay, now I can finish it. Okay, so 1/2 natural log of u plus c. Okay, what was u though? Yeah, it was x squared plus 1. So 1/2 natural log of x squared plus 1 plus c. I don't really need absolute value because it's x squared. So if you square something, it's going to be positive. So there, that's it. That's the answer. All right, so that's the kind of stuff you're doing. And see, that takes a while to get long divide it, long division, then integrate. And use substitution. Okay, so the problems are in the text, posted on Canvas here. Let's take a look.